Keep going.
Hey, good morning, forensic scientists. Today what we're going to be doing as we finish our unit on tires, we're going to be looking at a vehicle, a getaway vehicle. We have different getaway vehicles, and we're going to be studying and to see if we can figure out how fast the getaway car was going as it left the scene of a crime. The way we're going to do that is we're going to simulate that the getaway vehicle is dripping oil from its back end as it drives away, and we as forensic scientists can study the oil drops and do some science behind that to get the actual speed of the car. So, how are we going to simulate oil droppings in a car that doesn't have oil? Great question. If you look here, we have a device called a spark timer. Each group will have one of these, and you'll want to get some spark paper, which is this. You're going to want to feed the spark paper through the spark timer like so, and then you're going to want to attach the paper to the end of the car. It doesn't take that much tape. Maybe like that, okay? So make sure your paper is smooth so it doesn't get stuck in the machine. And now here's the great thing about this spark timer. Right here, these two metal pieces will leave marks in the paper at a constant rate. So if you see this button here, this is how you determine what the rate the oil drops, right? These are simulating the oil drops. This will tell us the rate the oil drops are being left. 10 Hz is 10 Hertz, and that means it'll leave 10 dots in 1 second. If you switch it to 60 Hertz, it'll leave 60 dots in 1 second. My recommendation is let's go 10 Hertz, so 10 drops of oil per second. Okay, so to recap here, the reason we're doing this, or the importance of this lab, if somebody were to come up to you and say, why are you doing this? Our end goal today is to be able to analyze oil drop data to figure out the velocity of a getaway car. Okay, so now here's the fun part. Once you're ready, you can come over here and turn your spark timer on. And you can see it's leaving the dots. We're gonna now turn our car on over here. Let it pull the paper through. Okay, so now the cool thing, turn our spark timer off, is if we have our ruler, we can come over here, and we know, we can pick any of these dots, and we notice that the dots are evenly spaced. So if we think about that, that means the car was moving at a constant speed, right? So let's check to make sure they're evenly spaced, which they are. So then the time it was between one dot to another is 1/10 of a second, right? So we want to get the car's speed in meters per second. So if I take this ruler and go to millimeters and measure the distance the car traveled, I see that it traveled about 1.5, right? So from this dot to this dot is about 1.5 centimeters. So it traveled 1.5 centimeters in 1/10 of a second. We want to know how far it traveled in 1 second. In other words, what's its total number of meters per second? Because that's how velocity is calculated, that's how velocity is talked about. So if it does 1.5 meters in 1/10 of a second, how many centimeters will it do in 1 second? So simple answer to that is to take this distance, and we're going to multiply that distance by 10. So if it goes 1.5 centimeters in 1/10 of a second, right? In 1 second, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We should expect this to be 15 centimeters. And what we see is it is exactly 15 centimeters. So the car's velocity, and this is the end, the car's velocity, and this car's velocity was 15 centimeters per second. So we now know the velocity of this escape car. Good job, forensic scientists.